In question 6, we want to find out if the NASDAQ is more volatile than the NYSE. So we want to know if the variance for the NASDAQ is greater than the variance for the NYSE. We have 31 NASDAQ daily closes and 46 random New York Stock Exchange daily closes. The NASDAQ standard deviation is 9.19 and the NYSE's is 5.51. I've copied the sample sizes and the sample standard deviations from the Cengage Now problem into my Excel spreadsheet. The larger sample standard deviation is 9.19. The larger sample variance is 84.4561. I found that by squaring the sample standard deviation. The smaller sample variance is found by squaring the smaller sample standard deviation. The f-stat, remember, is the ratio of the bigger sample variance divided by the smaller sample variance. So the numerator degrees of freedom is 30. The denominator degrees of freedom is 45. This goes in the numerator of the f-stat. That goes in the denominator of the f-stat. Hence, this is the numerator degrees of freedom, and this is the denominator degrees of freedom. The alpha level for the problem, the significance level for the problem, is 1%. In part B, we want to determine the critical values. But before we do that, we have to determine what our hypotheses are. So remember, NASDAQ, we want to know if NASDAQ is more volatile than the NYSE. So we want to know, that right there is indicating, that phrase there is the alternative hypothesis. So the variance for NASDAQ is greater than the variance for New York Stock Exchange. So the null hypothesis is less than or equal to. This is an upper tail test. So because it's an upper tail test, we're going to put NA in the left answer blank. And we need to get the upper critical value for this upper tail test in the right answer blank. So it's a one-tail test, so we divide alpha by 1. We're in row 0.01 and 45 of the F table. So let's find the F table. Okay. 0.01 and 45. That's the row we're in. We don't have a row 45. So instead of doing that, we're going to go to the F distribution calculator on my website. So denominator degrees of freedom is 45. 0.01 is the alpha level, and then the numerator degrees of freedom is 30. So 30, 45, and 0.01. So the F critical value is 2.14. And notice it is bigger than 1. The upper F critical values are always bigger than 1 because the hump of an F distribution is close to 1. All of the lower critical values for the F table would be less than 1, because again the hump is near 1, and a ratio of equal variances would have an F statistic that is near 1. The lower tail F tests are not performed because the population with the largest sample variance is placed in the numerator of the test statistic. It is unnecessary to find a lower critical value for the two-tailed F test because the test statistic is by definition larger than 1. I got to reiterate that point over and over and over. Going back to the Excel spreadsheet, the F statistic is the ratio of the bigger variance and the smaller variance. So here it is 2.7818. Copy that into Cengage now. We only need 2 decimal places, so 1/8, that becomes 2. Our test statistic is bigger than the upper critical value, which means we can accept the alternative hypothesis and reject the null. So the null can be rejected. So what does that say? We can actually say the NASDAQ is more volatile because we can reject the null outright. NASDAQ is more volatile than New York Stock Exchange. Check my work and we should get 100%. And we do.